Before modeling the handle, we'll use the same workflow as we did for creating the spout, with a few small variations. Let's switch to the front view. Set the display mode to solid and switch to edit mode. Also, change the selection type to face. Select the face of the container at the upper starting point of the handle. Press the E key, extrude the face just enough to mark the start of the handle, and position it correctly by following the reference image. Once this operation is complete, delete the face. In the same way, select the face at the lower starting point of the handle. Press E, extrude the face just a small amount, position it according to the reference below, and then delete it. In both cases, it might be helpful to enable X-ray view. Let's go back to object mode, and just like we did earlier when modeling the spout, let's add a reference circle. First, position the 3D cursor. So, press and hold the Shift key and right-click your mouse near the starting point of the upper modeling of the handle. Press Shift A and select Mesh, then Circle. Open the window in the bottom left corner of your screen and set these values. Set the number of vertices to 6, adjust the radius to 1 cm, and make sure the fill type is set to nothing. Now we can rotate, scale, and move the circle to better fit the reference image. Let's switch to a perspective view so we can more easily observe the area we're working on. As we can see, by assigning 6 vertices to the circle, the top and bottom parts have edges to which we can connect the mesh of the container instead of just vertices. To solve this problem, press the comma key on your keyboard and, from the pie menu that appears, select the local option. Alternatively, we can open the Transform Orientation menu located at the top center of the viewport and choose the local option. Press RZ30 followed by Enter to rotate the circle by 30 degrees around the Z-axis so that both the top and bottom have vertices where we can connect the mesh of the container. Let's set the orientation back to global. Select the container, set the working mode to edit mode and the selection mode to vertex. In the Modifiers tab, temporarily disable the on-cage parameter of the subdivision modifier. Now let's make sure to snap each vertex of the container's mesh to the corresponding vertex of the reference circle. Switch back to object mode and delete the circle. Go to the front view, select the mesh and change the working mode to edit mode. Using a loop selection, select the vertices we just worked on and reactivate the on-cage parameter. Also enable the X-ray view. Now we can proceed to extrude, rotate and scale each segment we add, always following the reference photo. Always try to position the extrusions by identifying strategic points where changes in direction and curvature occur, avoiding leaving too much space between one loop cut and another. If you need to go back to a loop cut in order to make some additional adjustments, always use the loop selection by pressing Alt and the left mouse button. This helps ensure you select the correct loop cut for your changes. This solution is preferable because it's faster, especially when dealing with relatively complex modeling like the one we're working on in this course. As we model, we can actually observe that the handle section doesn't really need to be scaled since it maintains the same size throughout its length. Let's stop modeling just before reaching the lower part. With the last extruded vertices selected, hold down the Shift key and perform a loop selection to also select the vertices of the container that we extruded at the beginning. Switch the selection mode to Edge or Borders. Right-click and from the window that appears, choose the Bridge Edge Loops option. In this way, Blender automatically creates a bridge between the selected vertices. Let's turn off the X-ray view and, in perspective view, rotate around the handle to observe the result. I would say there are a few small details we can fix. We need to make some adjustments to both the upper part and especially the lower part. In the first case, we can slightly narrow the attachment point of the handle to the container, working mainly on the Y-axis. Even though we don't have any side view to help us, let's try to make the modeling in these areas as realistic as possible. As for the lower part of the teapot, we definitely need to tighten the loop cut near the handle joint, again working along the y-axis. Then let's try switching between the front and perspective views to also check the vertical size of the joint. In this case, we need to work along the z-axis, making sure not to flatten the handle section too much. In short, as you can see, we need to proceed in exactly the same way as if we had this model in our hands and were shaping it with the same sensitivity and attention as a craftsman. In other words, we need to feel the consistency of the virtual material under our fingers, shaping it with gentle pressure where we need to define subtle details, and with more decisive gestures where we need to form the main masses. Just like with modeling clay or terracotta, it's a process of continuous addition and subtraction, where every action affects the overall balance of the piece. When we're satisfied with the result we've achieved, we rename the model we've been working on so far to Teapot Body in the outliner. Finally, we save the file incrementally,